I received a couple of requests for some help with the homework due Thursday, May 5th, in particular part C of the 2010 question number 5. The solution that Mr. Calculus provides is correct, but I'm going to write up a solution that it would be a little easier for us to understand, and this may help you with that part. So we have in this part a function defined, h of x defined by g of x minus 1/2 x squared. So what we want to do is find the critical points. That's where h prime is undefined and where h prime equals 0. So in order to do that, we need h prime. So we're going to find the derivative of the first term and the derivative of the second term, and this is our derivative. So g prime on the interval from -7 to 5 is never going to be undefined because g prime is defined. This is g prime. And this is defined for all of those values in that open interval, so we're good to go there. We just need to find where this equals 0. So to find where g prime of x minus x equals 0, this part I went over in the video a little bit. We want to find where the input matches the output on this graph here. So that's where I graphed the line y equals x. We saw 3, 3, and then this point here. So x equals 3 is one location where the first derivative is undefined. And then what Mr. Calculus showed, there's kind of no way around this part, but that circle, the equation for a circle that's centered at the origin is x squared plus y squared equals r squared. So since the radius here is 2, when I do r squared, I get 4. And if I solve this for y squared by moving the x squared over and then taking the square root of both sides, I get plus or minus 4 minus x squared. Since it's the top half of the circle, we just grab the positive value there. So what we want to find is we want to find, again, where the input matches the output, where the input is the same as the output. So what I'm going to do is replace y with x. So if we solve that, then we get a quadratic equation. If I slide everybody over to the left, we can factor out 2. And when we set this factor equal to 0, we get x equals plus or minus radical 2. Since we are dealing with where the input matches the output, it's only the positive value there, because you can see over here, if you go to radical 2 here, that's the input is negative, but the output is positive. So it's just this point here where x is radical 2 and this point here where x is 3. Now for the next part, now that we've identified the critical points, so we're looking for where x is 3 and where x is radical 2, what we can do instead of doing what Mr. Calculus did is we can do the first derivative test. And that's where we made the chart. So radical 2 would be here, 3 would be here because radical 2 is smaller than 3. And we want to test values to the left of 2. Now remember, we're on the open interval from -7 to 5. So we want to stick between those numbers. So what I'm going to do is test something in between radical 2 and -7. So I'm going to test x equals 0 to find the sign of h prime. And then I'm going to test something between radical 2 and 3, like 2, to find out if h prime is positive or negative. And then I'm going to test something over here like 4. And this method will be more familiar for us. So for h prime of 0, we're looking at where g prime of 0, the value of g prime is 0 minus 0. Now remember, this graph up here is g prime. So g prime of 0 is 2. So what I have here is 2 minus 0, and that gives me a positive. So that means in this interval, h prime is positive, which means h is increasing. And then if I go and test something between radical 2 and 3, such as 2, I'm going to do g prime of 2 minus 2. If I look back at the graph, g prime of 2 is 0. So I get a negative here, which means since I got a negative when I tested this value for h prime, that means the graph of h will be decreasing. And then finally, I'm going to test at x equals 4. So I need g prime of 4 minus 4. And g prime of 4 from this graph is going to be 0. And then you end up with a negative. So this part, for this interval from 3 to 5 there, you're going to have a negative for h prime, which means the function is decreasing. So if your function h is going from increasing to decreasing, then this is definitely a max location. And if you're going from decreasing and then still decreasing, this is neither. I hope that helps clarify how to do part C of that problem, because this would probably look a lot more familiar to you than the approach that Mr. Calculus took. Thanks for asking that question.